Hi, in this video, you will learn how to wire a room in the home that has receptacle installed as required and a 3-wire fan light outlet controlled by a double single pole switch. After watching this video and understanding the topics covered in this video, you will be able to wire such a room yourself if you have some manual skills. This video will take you from the scratch to completing the electrical installation in such a room. Wiring is also described in great detail and supported by articles from the latest edition of the National Electrical Code. Example of a room wiring according to the NEC with a 3-wire fan light outlet controlled by a double single pole switch. As an example of a habitable room is a medium-sized room, 15 feet by 12 feet, with 2 windows, hinged entrance door and a storage closet, 2 feet by 8 feet, total, 196 square feet. It is a brand new room or completely gutted. An electrical plan will be drawn for this room. Symbols commonly used on electrical plans that need to be known to draw a plan for the room. Duplex receptacle. Switch-controlled receptacle. Surface mount light outlet. Recessed light outlet. Ceiling fan. Ceiling fan with light. Single pole switch. 2023 NEC, National Electrical Code, requirements for such room. As per Article 210.52 of the 2023 NEC, receptacle outlets are required to be installed in this room and located in the locations specified in this article. In addition, Article 210.70, A.1, requires the installation of at least one lighting outlet, controlled by a wall switch located near the entrance to the room. For this room, an exception in the Article 210.70, A.1 also allows the receptacle to be controlled by a switch, instead of installing a light outlet. According to 2023 NEC Article 210.52, general purpose receptacle in the habitable rooms, excluding specific rooms defined by NEC, must be located as follows. There is no point on the wall more than 6 feet from the receptacle, measured horizontally along the floor line. Any wall space 2 feet or wider must have a receptacle. Receptacle installed in the floor or on the floor can be considered as a receptacle required if it is installed within 18 inches of the wall. Receptacle required by NEC for habitable rooms cannot be installed higher than 5.5 feet above the floor level. The switch must be installed so that its handle in the up position is no higher than 6 feet 7 inches from the floor, in accordance with Article 404.8, A, of the NEC 2023. The NEC does not specify the location of a light outlet or the number of lumens a light must provide in a given room in a home, but local regulations may require lumens per square foot in some areas for safety reasons. An electrical plan prepared for the room to be wired that meets the 2023 NEC requirements. How to select a branch circuit for this room. Article 220.41 of the 2023 NEC states that the minimum load in a dwelling unit, house, shall not be less than 3 volt-amperes per square foot of exterior floor area, excluding porches and areas that will not be used for habitable purposes in the future, which includes all receptacles rated 20 amps or less, lighting outlets and motors up to 1/4 horsepower connected to the lighting circuits. If a load of 3 volts-amperes per square foot must be calculated for the floor area described in Article 220.41 of the 2023 NEC for general lighting in a home, the total area to be wired is only 15 feet by 12 feet plus a storage area of 2 feet by 8 feet, for a total of 196 square feet. According to NEC, calculating the load per square foot, this area requires 196 square feet times 3 volt amperes equals 588 volt amperes general lighting load. When divided by the supply voltage, 588 volt amperes divided by 120 volt, the current is 4.9 amps. As per Article 210.23b of the 2023 NEC, a lighting branch circuit can be 15 or 20 amps and may be used to supply lighting outlets, receptacles, and utilization equipment, or a combination thereof, except receptacles located in specific locations such as laundry rooms, bathrooms, etc. When the load for this room is determined by the general lighting load calculation and the volt amperes power required for that room, we only need a fraction of the 15 or 20 amps branch circuit current as calculated. 4.9 amps divided by 15 amps equals 0.33% of the 15 amps branch circuit ampacity, and 4.9 amps divided by 20 amps equals 0.26% of the 20 amps branch circuit ampacity. So if the room load is unknown, a new 15 amps circuit will be perfectly sufficient, or you can draw power to that room from an existing branch of the house lighting circuits, as the load used in that room may be even lower than the calculations suggest. This is theoretical because even if the room is not wired, it still needs to be included as a future habitable space in the calculation of the general lighting load for the house per square foot, and if it is a new habitable space added, other electrical outlets already existing in the house can cover this space. The 180 volt amperes per square foot receptacle load calculation specified in 2023 NEC Article 220.14 does not apply for dwelling unit load calculations. In reality, the general lighting branch circuit must be calculated based on the load to be connected to the lighting branch circuit supplying the room. The NEC does not specify the number of outlets in a general lighting circuit. The number can be virtually unlimited, but good wiring practices recommend 10 to 15 outlets. The number of outlets should be selected depending on the load, because in some rooms, like the bedrooms, the load is low, while in others, such as living room, it may be higher. When selecting a branch circuit, it should also be considered that the cord-connected equipment to a branch circuit cannot be rated greater than 80% of the circuit rating per 2023 NEC Article 210.23b(1). And the continuous load connected to the branch circuit also cannot exceed 80% of circuit ampacity. Although a branch circuit may be 15 or 20 amps, in rooms such as a home office, bedrooms, living rooms, etc., and all the light outlets in the home, the optimal choice is to use a 15 amps branch circuit with 14 gauge wires for these installations. 14 gauge conductors are the smallest wires allowed for branch circuits in homes per 2023 NEC Article 310.3. Cables commonly used in homes with 14 gauge conductors, wires, are most flexible. Junction boxes can accommodate more wires, wires are easier to be spliced or connected, and cables are less expensive. In a room such as a home office or similar, one 15 amps branch circuit is sufficient to power lighting and equipment plugged into the receptacles. If the circuit is used solely for lighting, the number of connected luminaires, light fixtures, should be calculated based on their ratings, and consideration should be given to whether the load should be considered continuous under the load definition in Article 100 of the 2023 NEC. Typically, general lighting branch circuits in homes are wired with 14 gauge conductors. For house wiring, the most popular cables are NM, non-metallic sheathed cables with copper conductors of the various size and ampacity required to wire a specific area or appliance. All requirements for NM cable installation are specified in Article 334 of the 2023 NEC. The wiring for this home office or a similar room will be done using 14-gauge NM cable. Materials needed to install wiring in the above-mentioned habitable space, home office. For rough-in wiring will be needed 14. 2 NM cable. Receptacle, switch junction box. Ceiling light outlet junction box acceptable for fan support. Wire nuts. Staples. Nail plates. And cable stackers may also be needed. To complete wiring will be needed duplex receptacles, single pole switch, switch and receptacles wall plates, AFCI, arc fault circuit interrupter, circuit breaker, button type cable connector, box extender, may be needed. Measurement and marking of the room for installation of the electrical devices. Receptacle placement in the home office or similar room according to the 2023 NEC. And the drawn plan. The receptacles in this room must be placed as follows. No more than 6 feet from any openings in the wall, doors, fireplaces, etc. The distance between the receptacles cannot be greater than 12 feet. Any wall space 2 feet wide or more requires a receptacle outlet. The distance to and between receptacles must be measured along the wall line. To the center of the receptacle to meet the NEC requirement, no point measured horizontally is more than. At least one lighting outlet must be installed in a habitable room, controlled by a wall switch located near the entrance to the room. The NEC does not specify the location of a light outlet or its brightness, but other building and local codes may require this for a particular room. A single light outlet is usually located at the center of the room ceiling. Regarding the switch, the NEC only specifies the maximum height of the switch location, 6 feet 7 inches, and where it must be located, on the wall, but does not specify how far from the entrance to the room, near the entrance to the room, so other building and local codes and those having jurisdiction, inspectors, may require it. It is unacceptable to place the switch on the wall behind the door because this place does not meet the condition defined as near the entrance to the room. To locate a mark receptacle outlets on the walls, measure 6 feet along the wall from the opening, door, and mark on a stud or floor where the receptacle outlet will be placed along that distance. Repeat the same for the measurement from the other openings. Measure a distance of 12 feet from the already marked receptacle, and mark the location of the next receptacle in the same way, no further than 12 feet away. Repeat this step until all the receptacles along the walls are marked. If necessary, adjust the distances between receptacles and add more receptacle if needed. Measure small sections of walls, if any, and make sure they require a receptacle installation as required by the NEC. Wall requires a receptacle if it is 2 feet or wider. Measure the distance from the floor along the stud where the receptacle will be mounted, and mark the bottom of the receptacle junction box on this stud at the selected height. 14 inches is the most common distance from the floor to the bottom of the receptacle junction box. Repeat this step for each receptacle junction box in all locations. The most common distance is 14 inches from the floor to the bottom of the receptacle junction box, but this can be customized up to 5.5 feet. The entire receptacle must fit within this height, as permitted by the NEC. Marking the location where the switch will be installed. Measure the distance from the floor along the stud, where the switch will be mounted, and mark the bottom of the switch junction box on this stud at the selected height. 44 inches is the most common distance from the floor to the bottom of the switch junction box. 44 inches is the most common distance from the floor to the bottom of the switch junction box, but this can be customized up to 6 feet 7 inches as permitted by the NEC. Switch handle in the up position cannot be higher than 6 feet 7 inches from the floor. Light outlet marking. Measure the ceiling or floor, and mark the location of the light outlet, which is usually located in the center of the ceiling. Junction boxes. Many different junction boxes are available to suit this installation. In this example, 2 types of boxes have been selected that are best suited for this type of wiring. A non-metallic, nail-on Carlin 22.5 cubic inches junction box was selected for the receptacle outlets and switch. As a junction box for the light outlet in the center of the room, the commercial electric 12 cubic inches, non-metallic junction box rated for fan support was selected. Details of the Carlin, non-metallic, single-gang, nail-on junction box. This junction box is accepting only NM, non-metallic sheathed cables up to 10 gauge, and can be mounted to wooden material only. This junction box 22.5 cubic inches requires a wall at least 3 inches deep. Similar junction boxes with less capacity with shallower depth are also available. Front view of a single-gang Carlin junction box. Box size, volume in cubic inches 22.5 cubic inches. As per the exception specified in Article 314.17(2) of the 2023 NEC, the cable entering this type of junction box must be secured to a stud within 8 inches of the cable entering the cable knockouts because these knockouts do not have any cable clamps. Multiple cable entry through the same knockout is also allowed. The maximum number and size of wires that can fit in a box for ease of calculation. Each insulated wire counts as 1. All uninsulated bare wires counts as 1 up to 4 conductors based on the largest 1 volume of the wire plus 1/4 volume of each additional conductor. Each device, receptacle, switch, etc., counts as 2 based on largest volume of the conductor inside the junction box as per Article 314.16, b. 1, 4, 5 of the 2023 NEC. Example of a simple calculation. The number 11/14 on the box means that the junction box can accommodate 11 of 14 gauge, American wire gauge, wires. Calculation for 414, 2 NM cables, 4 white and 4 black wires, as 1 each, 4 plus 4 equals 8. 4 bare ground wires as 1. 1 device, receptacle, switch, etc., to be installed as 2. Total, 8 plus 1 plus 2 equals 11. It means that the junction box can accommodate a maximum of 414. 2 NM cables and 1 device. The above calculation shown is simple for same gauge wire size. Calculations when there are mixed conductors, wires, inside a box are more complicated and can be made by calculating the value required for each conductor according to Table 314.16, b(1), or more easily, by calculating the number of conductors using the number of conductors allowed in that box and described for a largest wire size inside, for example, 10 wires of 12 gauge or 9 wires of 10 gauge. Knockouts for inserting the cables into the junction box. Nails for mounting the junction box to the wooden studs. Mounting holes for electrical devices. Side view of a single gang Carlin junction box. 1/2 inch distance stubs showing the junction box offset from the stud during installation to match standard house wall finishing. Drywall thickness 1/2 inch. Markings showing the offset of the junction box from the stud during installation for different wall finish thicknesses. Nail tips driven into the wood during installation. Top, or bottom, and rear view of the junction box. Nails at the top and bottom of the junction box in their guides. Commercial electric 12 cubic inches a non-metallic junction box, acceptable for fan support, selected for this type of installation, on the center of the beam. Acceptable for fan support. Screw that secures the junction box to the joist. Screws securing the fan or lighting fixture, direct mounting to the joist. Button type, push-in cable connector. Holes in the junction box for screws securing the fan or luminaire, light fixture to the ceiling beam. Cable knockouts. Junction box cover. Installation of junction boxes. Once the entire room has been measured and marked, attach the junction boxes for the receptacles and switch to the studs. To install a nail on junction box, hold the junction box on the side of the stud and align the bottom of the box with a marking sign on the stud. Make sure the front of the junction box is far enough from the front of the stud to match the wall finish, usually 1/2 inch drywall. 1/2 inch distance stubs should evenly touch the front of the stud. While holding the junction box at side of the stud, drive the nails of the box into the stud. Junction boxes mounted to the studs. If necessary, add a piece of wood to move the junction box further away from any wall elements, door trim, wall corner, etc., to create enough space for the device wall plate installation. According to Article 314.17, b, of 2023 NEC, more than one cable can enter through the same junction box knockout. The cable must be secured no more than 8 inches from the cable entry point into the junction box, measured along the cable. And the cable sheath must extend at least 1/4 inch into the junction box. As per junction box calculations, this junction box can accommodate a maximum of 414, 2 cables and an electrical device, or 312, 2 cables and a device. Any other cable combination must be calculated based on the volume of the junction box. Vapor-tight junction boxes for external walls may be required to meet energy code requirements. Light outlet junction box installation. Install the ceiling light outlet junction box. If any light outlet junction box in a habitable room is located in a ceiling, the light outlet junction box must be rated, for fan support, or provide direct access to the building structure capable to support the fan in accordance with Article 314.27 A.2 and Article 314.27 C of the 2023 NEC. Also, if you plan to control the fan and light separately from a wall switch in the future, it is good practice to install a 3-wire cable, instead of a 2-wire, to this type of outlet. NEC does not require this. The junction box for the ceiling light is attached to the beam using the junction box mounting screw. Drilling holes for cables. The cables are run through structural wall members, studs, beams, etc., which must have opening in them to allow for their passage. In wood construction, cable holes can be drilled into structure wall members, but certain drilling rules must be followed as outlined in the NEC and other building and local codes. Holes for routing cables through wall studs can be drilled at any height in the center of the stud, on the wider side in the wall, but are generally located approximately 30 to 40 inches above the floor in each stud along the wall where they are needed. Side view of a 2 by 4 inches stud, wider side. The drilled hole should be no larger than 7/8 inch. Standard drill bit size can be smaller, but no smaller than 1/2 inch. The edge of the hole should be no closer than 1 1/4 inch from the edge of the stud. Drilled hole. Drilled 7/8 inch hole in the center of the 2 by 4 stud. 1/16 inch thick steel nail plate. If the edge of the hole is less than 1 1/4 inch from the edge of the stud, secure the cable in the hole with a 1/16 thick steel nail plate of the appropriate length. For holes greater than 7/8 inch in diameter, and if the edge of the hole is less than 1 1/4 inch from the edge of the stud, a steel nail plate must be used on both sides of the stud. Cable protected with a nail plate. If necessary, multiple holes can be drilled in the stud. A single stud can be drilled or bored to a width no greater than 60% of the stud width, and the hole should be no closer than 5/8 inch from the edge of the stud in non-load-bearing walls, and no greater than 40% of the stud width in load-bearing and exterior walls. Double studs in all walls can be drilled up to 60% of their width. If the edge of the hole is less than 1 1/4 inch from the edge of any stud, the cable must always be protected with a steel plate. In external or load-bearing walls, studs may have notches extending up to 25% of the stud width. And in non-load-bearing walls, studs may have notches extending up to 40% of the stud width. The cutout with the cable must be protected with a steel plate. The cutout must not be in the same place where the hole is drilled. When drilling the top and bottom wall plates, the same drilling rules apply as for studs. Hole were drilled in the top wall plate for cables. Holes in the ceiling beams, joists. In the ceiling beams, joists, holes may be drilled no larger than 1/3 of the beam, joist width, and at least 2 inches from the top and bottom of the joist to the edge of the hole. For multiple holes, the distance between the holes must be twice the diameter of the larger hole. The distance between these two holes must be twice the diameter of that larger hole. To drill a hole, maintain a distance of at least 6 inches from the end of the beam support point on its edges. For engineered beams, check the beam specifications for drilling holes in the beam. Holes drilled in the ceiling beams. When routing cables through metal studs, a snap-in sleeve must be used in each stud where the cable is installed. Requirements for cable installation in wood-framed buildings. All cables must be installed and supported in a neat and professional manner so as not to be damaged during normal building use, in accordance with Article 110.12 of the 2023 NEC. Cables installed and routed over beams, through studs and in horizontal grooves are usually naturally supported. NM cable, non-metallic sheathed cable, Romex cable, is described in the 2023 NEC, Article 334. As per Article 334.30 2023 NEC, non-metallic sheathed cable shall be supported and secured with staples, cable ties, straps, hangers or similar hardware and installed in such a way as not to damage the cable. Some approved, listed, materials for supporting NM cables: staples, cable stackers, cable ties. Requirements for the installation and support of NM, non-metallic sheathed cable. The NM cable entering the enclosure must be supported no more than 12 inches from the enclosure entrance. No more than 12 inches from the entrance into the enclosure, junction box. The distance between the supports shall not exceed 4.5 feet. No more than 4.5 feet between supports. The NM cable should be stapled on its flat surface, not on its edge. The NM cable should be stapled on its flat surface, not on its edge. The edge of a cable stapled to a stud, when the cable is run parallel to the stud, must be at least 1¼ inch from the edge of the stud in accordance with Article 300.4 d of 2023 NEC. Cables must not be stapled closer than 1¼ inch from the edge of the stud. If staples are used to support cables, they must be approved for supporting NM cables. Do not drive staples too hard into the cables. The staples should be driven in hard enough to hold the cable in place, but not too hard that it damages the cable. Driving the staple too hard can damage the cable. Do not drive a staple over an existing staple when adding and securing a second cable over the previously installed one. The staple must contact the cable with its flat surface, not its sharp edge. No more than 2 cables may be stapled together with the same staple. Although the NEC does not specify how many cables can be stapled together, almost all staples are designed to staple a maximum of 2 cables with one staple and must be used in accordance with Article 110.3b of the 2023 NEC, which states that this should be done in accordance with the manufacturer's instructions. Do not damage the cable when removing the staple. If it is not possible to secure the cable with staples, too little space, a cable tie or other means of supporting the cable must be used as permitted by the NEC. If 1 1/4 inch distance from the edge of the stud to the edge of the cable cannot be maintained, use hangers, stackers, etc. to support the cable and pull the cables away from the stud. Also, when running multiple cables along a stud, use hangers, cable ties, or other means. A 7/8 inch diameter hole drilled in a 2 by 4 inches stud, actually 1.5 by 3.5 inches, for the cable works perfectly because it leaves a 1 1/4 inch margin on each side of the hole to the edge of the stud, so the cable running through this hole doesn't need a protection once installed. Since the NEC does not specify this in detail, in practice up to 3 nm cables, 14 gauge or mixed with 12 gauge, can be pulled through a 7/8 inch drilled hole, but the correction factors in Articles 334.80 and 210.15 c of the 2023 NEC regarding cable ampacity when grouped together must be taken into account. Approved 1/16 inch thick steel nail plate. The cable must be protected from physical damage and where there is a risk of nail penetration. The cable must be protected with a steel sleeve or plate at least 1/16 thick as per Article 300.4 of the 2023 NEC. According to Article 300.14 of the 2023 NEC, once a cable enters a junction box, the free wires exiting the cable must be at least 6 inches long and extend 3 inches beyond the junction box opening if the junction box opening is less than 8 inches in any dimension, so the cable entering the junction box must be long enough to be properly spliced. In practice, the cable should be between 12 and 18 inches long when entering the junction box so that it can be spliced easily and correctly. The cable sheath must extend no less than 1/4 inch beyond the junction box entrance or its cable clamp according to Article 314.17b and Article 334.19 of the 2023 NEC. Class 2, Class 3 low-voltage cable and communication cable shall not occupy the same opening or raceway as a power cables, unless they are separated by a partition or are located within 2 inches of each other in accordance with Article 725.136 and Article 800.133b. Installation of wiring in the home office or similar room. Cable routing. To make it easier to understand, the plan will be transformed and instead of the device symbols it will show the location of their junction boxes to clarify the installation of cables between these junction boxes. Room layout after conversion, showing location of junction boxes. As mentioned earlier, 14 2nm cable will be used to wire this room because in a room such as a home office or similar room, one 15 amps branch circuit is sufficient to power the lighting and portable equipment. This 14-gauge, 14 2nm wire in a 15 amps lighting branch circuit must be protected by a 15 amps overcurrent device, circuit breaker, and can have a maximum load of 15 amps per Article 210.24 and Table 210.24 I of the 2023 NEC. The 14 2nm cable contains 3 conductors, wires. Bare wire, equipment grounding conductor, ground wire. White wire, grounded conductor, neutral wire. Black wire, ungrounded conductor, hot wire. Run the power supply cable from the electrical panel where the circuit will be connected to any of the installed junction boxes. The junction box for the light outlet chosen for this installation has a capacity of 12 cubic inches, so 214. 2 cables or 114, 2 and 114, 3 cable can fit in it, according junction box fill calculation. To use this junction box as a junction box containing a power supply, feeder cable, a 14 3nm cable must be used between the light outlet and the switch junction box to control this light outlet. In this example, the junction box where the branch circuit cable from the panel board will be installed is the junction box located near the door. When installing cables, keep in mind how many cables will fit in the chosen junction box. The junction box, Carlin 1 gang 22.5 cubic inches, chosen for the receptacles and switch installation in this room can accommodate a maximum of 414 2nm cables and a device, as shown in the junction box fill calculation. The easiest way to connect junction boxes is to run a cable from one box to the other. Each junction box will have a maximum of 2 cables, daisy chain wiring. The 14 2nm cable is installed from the panel board to the first receptacle junction box. To connect all junction boxes in a daisy chain connection, run the cable as follows. From the junction box to which the circuit cable from the panel board has already been run, the same type of cable should be run to the next receptacle junction box, and to the next, and the next, and the next, and the next, and to the switch junction box, and to the light outlet junction box. This is example 1 of how this room could be wired. All receptacle junction boxes have 2 cables, a cable from the power source and a cable to other electrical outlets, that will be spliced, connected. The switch junction box have 2 cables, a cable from the power source and a cable to the light outlet, that will be spliced. The light outlet junction box has a cable from the switch. In this example, the fan light fixture will be fully controlled by the wall switch. To control the fan and light independently from a switch junction box, the cable connecting the switch to the light outlet must be a 3-wire cable. A double single pole switch or fan light controller must be installed in the 1-gang junction box to independently control the fan and lighting of the fan light fixture. To control the fan light fixture by independent single pole switches, the 2-gang switch junction box must be installed. Once all cables are installed and inserted into the junction boxes, you will need to splice the wires inside these junction boxes to prepare them for rough-in inspection and for installing electrical devices once the finishing work is complete. The length of the cable entering the junction box should be between 12 and 18 inches to allow for easy and proper connection of the wires. The cable must be protected from physical damage where required. The cable sheath must extend no less than 1/4 inch beyond the junction box entrance. Cable splicing. Splicing is the joining, twisting together, two or more separate wires, conductors, inside a junction box. Splicing of the conductors must be made using devices identified for such use as per Article 110.14, b. 2023 NEC. The most commonly used splicing device for connecting wires is wire nuts. There are different types of wire nuts available. Wire nuts must be listed as per Article 110.3 of the 2023 NEC and are designed to connect a specific number of wires using a specific wire nut. Splicing ground wires using green wire nut. Separate the ground wires, bare, from the others and push the ground wires towards the back of the junction box. Twist the ground wires. Hold them in your fist. This will provide a minimum wire length of 6 inches, which is required by NEC, and cut the shorter wire at the front of your fist. Thread the long wire through the hole in the green wire nut and turn wire nut clockwise until it twists the wires and is no longer loose. Neatly fold and insert the wire connection into the junction box, leaving the pigtail wire outside the junction box. Any wire nut can be used to connect equipment grounding conductors, ground wires. But the green wire nut is specifically designed for connecting ground wires. The green wire nut can only be used to splice the equipment grounding conductors and is designed to splice bare ground wires. Non-metallic sheathed cables always have the bare equipment grounding conductors. This wire nut has a hole at one end through which one of the bare wires is pulled during connection, which then becomes a pigtail wire that is connected to the ground terminal of the electrical device or equipment. Wire nuts must be listed and used in accordance with manufacturer instructions as per Article 110.3 of the 2023 NEC. The green wire nut allows the connection of the minimum and maximum number of wires and wire combinations specified in the manufacturer specifications. For 14-gauge copper solid wires, this is typically 2 to 5 wires. Equipment grounding conductors must always be connected together to provide effective ground fault path for current as per Article 250.148 2023 NEC. The cut wires for splicing, excluding wire for the pigtail, must be at least 6 inches long from the point where they exit the cable sheath, and must also extend at least 3 inches beyond the junction box opening if the opening is 8 inches or less in any dimension, per Article 300.14 2023 NEC. The cable sheath must extend no less than 1/4 inch beyond the junction box entrance or its cable clamp according to Article 314.17, b, and Article 334.19 of the 2023 NEC. When splicing the wires, it is enough to make 3 to 5 twists of the wires, as too many twists can damage the wires. Pigtail wire emerging from green wire nut hole after connection. When it is necessary to splice more ground wires than can be connected with a single wire nut, use a larger wire nut, or separate the ground wires into parts and splice them separately. Then connect them together using wire jumpers between the connections. In addition, the pigtail grounding wire connected to an electrical device must be the same size as the grounding conductor of the circuit supplying this device. Splicing ground wires using standard wire nut. Separate the ground wires, bare, from the others and push the ground wires towards the back of the junction box to bend them. Hold the ground wires in your fist. This will provide a minimum wire length of 6 inches required by NEC, and cut them off at the front of your fist. Take a piece of bare wire for the pigtail and using pliers twist the wires together clockwise. Secure the connection with a wire nut. Neatly fold and insert the wire connection into the junction box, leaving the pigtail wire outside the junction box. A medium-sized universal wire nut that can be used for any connection for the number of wires specified in its specifications. The universal, standard wire nut allows the connection of the minimum and maximum number of wires and wire combinations specified in the manufacturer specifications. For 14-gauge copper solid wires, this is typically 2 to 6 wires. When using a universal wire nut to splice ground wires, add the pigtail wire needed to connect the ground wires to the electrical device. The cut wires for splicing must be at least 6 inches long from the point where they exit the cable sheath, and must also extend at least 3 inches beyond the junction box opening if the opening is 8 inches or less in any dimension, per Article 300.14 2023 NEC. The cable sheath must extend no less than 1/4 inch beyond the junction box entrance or its cable clamp according to Article 314.17 (b) and Article 334.19 of the 2023 NEC. The size of the pigtail wire must not be smaller than the size of the wires of the cables to be spliced. When grounding conductors of different circuits are spliced together in a junction box, the ground wire pigtail connecting the electrical device to the spliced grounding wires must be the same size or larger as the grounding conductor of the circuit to which this device will be connected. When splicing the wires, 3 to 5 twists are sufficient, as too many twists can damage the wires. A pigtail wire has been added to connect the ground wires to the electrical device. The ground wires can be spliced using a green wire nut, and one pigtail wire from this splicing can be connected to electrical devices in a daisy chain connection. Or the ground wires can be spliced with multiple pigtail wires using a standard wire nut, so that each device installed in a multi-gang junction box will be connected using an individual ground wire. A standard wire nut may also provide one pigtail wire that can be connected to electrical devices in a daisy chain connection. Splicing neutral and hot wires using wire nut. Separate the wires to be spliced from the other ones. Fold and push the wires towards the back of the junction box. Hold them, grab them and cut them in front of your fist. To make a pigtail, take a piece of the wire of the same size and color corresponding the wires that will be spliced. Strip about 1/2 inch the insulation from the end of this wire, as well as from the ends of the wires to be spliced coming out of the junction box. Using pliers and a wire nut, splice the pigtail and other wires together. Neatly fold and insert the wire connection into the junction box, leaving the pigtail wire outside the junction box. One of the medium-sized universal wire nut that can be used for any connection for the number of wires specified in its specifications. For 14-gauge copper solid wires, this is typically 2 to 6 wires. To splice the wires, strip approximately 1/2 inch of wire insulation from their ends. The cut wires for splicing must be at least 6 inches long from the point where they exit the cable sheath, and must also extend at least 3 inches beyond the junction box opening if the opening is 8 inches or less in any dimension, per Article 300.14/2023 NEC. The cable sheath must extend no less than 1/4 inch beyond the junction box entrance or its cable clamp according to Article 314.17(b) and Article 334.19 of the 2023 NEC. A better connection is achieved by twisting the ends of the wires with pliers and screwing a wire nut onto these twisted wires. Always twist the wires clockwise during splicing. The size of the pigtail wire must not be smaller than the size of the wires of the cables to be spliced. 3 to 5 twists of the wires when splicing are sufficient, as too many twists can damage the wire insulation. Never connect neutral wires of different circuits together unless they are from a multi-wire circuit sharing the same neutral wire. Neutral wires should only be connected together if they belong to the same circuit. Splicing the junction boxes for wiring the room. Cable run between the junction boxes in this example. Splicing the receptacle outlet junction box with the cable from the power source and the cable to the other electrical outlets, 2 cables. Cable from the power source. Cable to the other electrical outlets. All of these 2 cable junction boxes are spliced in the same way. 2 cable receptacle junction box. Cable from the power source. Cable to the other electrical outlets. NM cable must always be secured to the building structure within 12 inches of the cable entry into the junction box per 2023 NEC Article 334.30, but when the junction box does not have cable clamps, the cable must be secured within 8 inches of the cable entry into the junction box per the exception specified in Article 314.17(2) 2023 NEC. In addition, the NM cable sheath must extend no less than 1/4 inch beyond the junction box entry or cable clamp. Sketch of the wire splicing connection inside the junction box. When removing the cable sheath, leave at least 1/4 inch cable sheath length beyond the cable entry as required by NEC. Splice the ground wires using a wire nut, as the grounding conductors, wires, must always be connected together to provide effective ground fault path for current as per Article 250.148 2023 NEC. Trim all wires to 6 inches or longer, as wires must be at least 6 inches long from the point where they exit the cable sheath, and must also extend at least 3 inches beyond the junction box opening if the opening is 8 inches or less in any dimension, per Article 300.14 2023 NEC. Spliced, connected, wires inside the junction box. Open the selected cable knockouts in the junction box. Insert the installed cable into this knockouts and secure it no further than 8 inches from the junction box entrance, in accordance with NEC requirements for this type of junction box. Remove the cable sheath. The cable sheath should extend no less than 1/4 inch beyond the enclosure, junction box entrance. Separate the ground wires, bare, from others. Bend and push the ground wires towards the back of the junction box. Twist the ground wires. Hold them in your fist. This gives you a minimum length of 6 inches from the box entrance, required, and cut the shorter wire at the front of your fist, leaving the longer one for pigtail wire. Thread the long wire through the hole in the green wire nut and twist it clockwise. Neatly fold and insert the ground wire connection into the junction box, leaving the pigtail wire outside the junction box. Trim the remaining wires to no shorter than 6 inches as required by the NEC, fold them and insert them into the junction box. Installation of the paddle fan with light in place of a center light fixture to which a 3-wire cable is installed from the switch junction box, and the fan light is controlled by a combination type, double, single pole switch. All receptacles are wired in the same way as shown earlier, only from the switch junction box, instead of the 14.2 nm cable. A 3-wire cable of the same size, 14.3 nm, will be installed. New colors are being introduced by manufacturers for NM cable sheath to visually distinguish them, but this is not a NEC requirement. For 14.3 nm cable, the sheath new color is blue. 14.3 nm cable installed between the switch junction box and the light outlet junction box. The 14.3 nm cable contains 3 conductors, wires. Bare wire, equipment grounding conductor, ground wire. White wire, grounded conductor, neutral wire. Black wire, ungrounded conductor, hot wire. Red wire, ungrounded conductor, hot wire, second. Splicing the single pole switch junction box with the cable from the power source and the cable to the light outlet, 2 cables. Cable from the power source. Cable to the light outlet. 2 cable single pole switch junction box. Cable from the power source. Cable to the light outlet. NM cable must always be secured to the building structure within 12 inches of the cable entry into the junction box per 2023 NEC Article 334.30, but when the junction box does not have cable clamps, the cable must be secured within 8 inches of the cable entry into the junction box per the exception specified in Article 314.172 2023 NEC. All junction boxes for switches installed in bathrooms, hallways, stairwells, and other habitable or may become occupied rooms must have a grounded, neutral conductor as defined in Article 404.2 c of the 2023 NEC. In addition, the NM cable sheath must extend no less than 1/4 inch beyond the junction box entry or cable clamp. Sketch of the wire splicing connection inside the junction box. When removing the cable sheath, leave at least 1/4 inch cable sheath length beyond the cable entry as required by NEC. Splice the ground wires using a wire nut, as the grounding conductors, wires, must always be connected together to provide effective ground fault path for current as per Article 250.148 2023 NEC. Splice the neutral wires of both cables. Trim all wires to 6 inches or longer, as wires must be at least 6 inches long from the point where they exit the cable sheath, and must also extend at least 3 inches beyond the junction box opening if the opening is 8 inches or less in any dimension, per Article 300.14 2023 NEC. Spliced, connected, wires inside the junction box. Remove the cable sheath. The cable sheath shall extend into the junction box not less than 1/4 inch. Group the ground wires, bare, together, separate the longer pigtail wire, trim the remaining wires to no shorter than 6 inches. Connect the trimmed wires to the longer pigtail wire using the green wire nut, and insert the connected wires into the junction box. Group the neutral, white, wires, cut them to no shorter than 6 inches. And strip the ends of the wires about 1/2 inch. Twist the wires and splice them with a wire nut. Insert spliced wires into the junction box. Group the remaining wires and pigtail wire and cut them to no shorter than 6 inches. Insert the trimmed wires into the junction box. Splicing the fan light outlet junction box with the cable from the switch, 1 cable. Cable from switch. 1 cable fan light outlet junction box. Cable from the switch. NM cable must always be secured to the building structure within 12 inches of the cable entry into the junction box per 2023 NEC Article 334.30. In addition, the NM cable sheath must extend no less than 1/4 inch beyond the junction box entry or cable clamp. Sketch of the wire splicing, connection, inside the junction box. When removing the cable sheath, leave at least 1/4 inch cable sheath length beyond the cable entry as required by NEC. Trim all wires to 6 inches or longer, as wires must be at least 6 inches long from the point where they exit the cable sheath, and must also extend at least 3 inches beyond the junction box opening if the opening is 8 inches or less in any dimension. Spliced, connected, wires inside the junction box. During drywall installation, temporarily cover the wires in the junction box with the supplied cover. Installation of electrical devices. Once the necessary inspections have been done where required and the walls have been finished, the electrical devices can be installed. Installation of the duplex receptacles. There are two types of duplex receptacles used: traditional and decora. Both receptacles are made the same way, they only differ in the front face look. All receptacles installed in residential buildings must be tamper-resistant (TR) type, as per Article 406.12(1) of the 2023 NEC. Tamper-resistant duplex receptacle. Article 406.12(1) of the 2023 NEC, National Electrical Code, states that all 15 and 20 amps, 125 and 250 volts non-locking type receptacles installed in all dwelling unit must be listed tamper-resistant type. Duplex receptacle, front view. Yoke. Ground terminal, green screw. Neutral terminal, silver screws. Hot terminal, gold screws. Ground slot for grounding pin of the plug. Neutral slot for neutral blade of the plug, larger, wider on the left side of the receptacle. Hot slot for hot blade of the plug, smaller, narrower on the right side of the receptacle. The neutral and hot slots are covered by a shutter of the safety, tamper-resistant, mechanism inside the receptacle. But the grounding pin slot is not. The TR mark indicates a tamper-resistant receptacle. Rating of the receptacle and its certification listing label. Screws securing the receptacle to the junction box. Threaded hole for mounting the receptacle wall plate. Cuttable receptacle yoke ears supporting the device on the wall that can be removed if necessary for certain installation. A duplex receptacle consists of two receptacles on one yoke which bonds the grounding terminals, and the current carrying terminals are connected by removable tabs between the terminals. Rear view of the duplex receptacle. Ground terminal, green screw. Neutral terminal, silver screws. Hot terminal, gold screws. Push-in, neutral and hot terminals that accept only 14-gauge solid copper conductors in a 15 amps branch circuit as specified in the device description. Push to release tabs to remove inserted wire. Side view of the receptacle with ground and neutral terminals. Side view of the receptacle with hot terminal. The duplex receptacle consists of two glued parts and is not repairable. Front part and rear part. View of the inside of the receptacle after opening. Front part has safety, tamper-resistant mechanism inside its base. The rear part contains female hot contacts with connection terminals and a yoke with a female ground contacts with a ground terminal. Tabs at the base of the front of the receptacle that fit over tabs at the base of the rear of the receptacle to make the two parts easily fit together and hold the two parts firmly together when glued together. The tabs that must be removed when separating a duplex receptacle into two separate single receptacles. When the tabs are removed, two separate, single receptacles are created. Connection terminal with the tab. And after its removal, female hot contact removed from its base. Female contact that firmly holds the plug blade. one of the push-in spring connection terminal that is not recommended for connecting wires, as it provides a poor connection that can cause overheating and damage to the receptacle, or even a fire. Tamper-resistant receptacle shutter mechanism inserted into the front part of the receptacle. Shutter mechanism removed from the receptacle front base. Interior view of the receptacle shutter mechanism. Shutter and the shutter body. The rounded corner of the shutter, the side that contacts the shutter body spring. Closer view of the shutter body. A spring that forces the shutter to close the slots of the receptacle after the plug is removed. Niche for the shutter balance cone. 2 pairs of pins, one of which holds the shutter in the shutter body and the other holds the shutter mechanism in the front base of the receptacle. The tab holds and stabilizes the shutter mechanism from the side in the front base of the receptacle. View of the inside of the shutter. A cone that fits into the recess of the shutter base. Flat side of the shutter that fits into the recess in the front base of the receptacle. A conical slot that fits into the conical post in the inner front base of the receptacle. A shutter balance cone that slides into a recess in the shutter base. When the shutter is pressed down evenly during plug insertion, the part of the shutter that covers the slot of hot female contact inside the receptacle before the shutter is pressed, and the other side of the same shutter that covers the hot slot in the front base of the receptacle from which the shutter will be pressed. The edge of the shutter that holds the shutter in place at the base of the shutter. When the spring presses the shutter to the side, the flat part of the shutter that covers the hot slot in the front base of the receptacle, preventing contact with the hot female contact inside the receptacle. When trying to insert an object into the receptacle slot, the flat part of the shutter that covers the neutral slot in the front base of the receptacle, preventing contact with the neutral female contact inside the receptacle. When trying to insert an object into the receptacle slot, the shutter is stopped by the edge of the shutter base. As the spring presses against the shutter, and the pins hold the shutter inside the shutter base. Conical side of the slot in the shutter that slides over the conical post in the front base of the receptacle when the shutter is balanced and pressed evenly. The other, flat side of the conical slot in the shutter that holds the shutter in place on the flat side of the conical post in the front base of the receptacle. When the spring is released and the shutter returns to its previous position. The front pair of pins that holds the shutter body in the front receptacle base, and the tab that holds and stabilizes the shutter mechanism from the side in the front base of the receptacle. Shutter mechanism removed from front the receptacle base, and shutter removed from shutter base. The flat surface of the shutter fits into a recess in the base of the front receptacle and covers both receptacle slots, preventing any object from being inserted into these slots. The grounding slot in the receptacle is always open. How the shutter mechanism works in a tamper-resistant receptacle. Attempting to insert a thin object into only one of the receptacle slots causes the shutter mechanism to block entry because the shutter slider is unbalanced. preventing it from being moved inwards and to the side to expose the slots and allow the male blades of the plug to be inserted into the female contacts of the receptacle. When inserting a thin object into only one slot of the receptacle, pressure is exerted on one side of the shutter, causing the other side of the shutter to deflect toward the front of the receptacle in the receptacle base recess. This unbalances the shutter balance mechanism, causing the shutter to remain in the same position, blocking the opening of the receptacle slot. When into both slots of the receptacle is inserted object, plug, which presses equal and simultaneously on the shutter, balancing it. The shutter slides at the same time into the receptacle and to the side, which causes the object, male blades of the plug, to slide into the receptacle slots and engage with the female contacts inside the receptacle. One more time. When inserting the plug blades into the receptacle slots, their ends press evenly and simultaneously on the shutter. The shutter mechanism becomes balanced, and with continued pressure on the plug, the shutter cone begins to slide into the shutter cone recess in the shutter base, at the same time as the shutter cone slides into its recess in the shutter base. The conical side of the shutter slot slides off the conical post in the front base of the receptacle, while the blades of the plug, which pressing the shutter, move it inwards. The conical shapes of the shutter balance mechanism cause it to move the shutter slides not only inwards, but also to the side, as the plug presses against the shutter and moves it in and to the side. The ends of the plug's blades slide across the flat surface of the shutter until the shutter moves enough to open the slots. Opening the slots causes the plug blades to drop into the slots and engage with the female contacts inside the receptacle. When the plug is removed from the receptacle slots, the spring that constantly presses the shutter moves it back to its previous position, which causes the slots of the receptacle to be covered again. Uneven and non-simultaneous hard pressure on the slots of the receptacle will unbalance the shutter mechanism, preventing the plug from being inserted and consequently damaging the receptacle tamper-resistant mechanism. The terminals of the receptacles are usually rated for only one wire under one screw. Push-in terminals which accept 14-gauge solid copper conductors, wires, only. It is not recommended to use push-in connections for receptacles, especially those with high current draw, due to poor connection which may cause damage to the device, overheating, burning or even fire. The tabs that must be removed when separating a duplex receptacle into two separate single receptacles. A properly spliced junction box for a receptacle should have 3 or 5 wires that will be connected to the receptacle. If a receptacle is connected to a branch circuit supplying more than 2 receptacle outlets, the receptacle cannot be rated less than specified in Table 210.21, B3, of the 2023 NEC, which states that for a 15 amps branch circuit, the receptacle must be rated at 15 amps. Rating of the receptacle. A duplex receptacle is considered two receptacles as defined in Article 100 of the 2023 NEC. Per Article 406.4a, 2023 NEC, all receptacles installed on 15 or 20 amps branch circuits must be grounding-type receptacles. The grounding-type receptacle must be connected to the equipment grounding conductor of the branch circuit in accordance with Article 250.146 of the 2023 NEC. Receptacles should be mounted using the hardware provided with the device or machine screws with a 32 threads per inch. Do not use drywall screws, as per Article 406.5 2023 NEC. Do not connect more than 2 wires to the hot or neutral terminal of the receptacle. Instead, properly splice the wires in the junction box before connecting them to the receptacle. Wires should be tightened to a torque of 14 to 18 inch-pounds for standard electrical devices unless otherwise noted by the manufacturer on the device or in its installation instructions. Without using a torque screwdriver, the wire under the electrical device screw should be tightened firmly, but not too tight so as not to damage the wire and the threads of the screw or nut. Never connect more than one ground wire to a single ground screw unless it is rated for multiple wires, as this creates a poor connection and does not provide a reliable ground fault current path. Instead, splice all ground wires together and connect only one wire under the ground screw. It is acceptable to wrap the ground wire around the ground screw to pass the ground wire to another device in a daisy chain connection. Use the screw terminals of the receptacle instead of push-in terminals. Using push-in terminals of the receptacle, especially at maximum current flow and continuous load, does not guarantee a good connection, which may cause the receptacle to overheat and, consequently, damage or even fire. Always connect the wires clockwise, not counterclockwise, because connecting clockwise pulls the wire in and secures it, while connecting counterclockwise pushes the wire out, which degrades the quality of the connection and makes it poor. When attaching the receptacle to the junction box, pay attention to the gap between the upper edge of the junction box and the surface of the installed drywall. The gap between the finished surfaces with noncombustible material and the top of the installed junction box must not exceed 1/4 inch according to Article 314.20 of the 2023 NEC. Where surfaces are finished with combustible material, extensions should always be installed to extend the junction boxes to such surfaces. Junction box extender, adjustable depth, with mounting screws. If the gap between the drywall surface and the top of the installed junction box is 1/4 inch or more, a junction box extension must be installed, per Article 314.20 and 314.22 of 2023 NEC. If the gap between noncombustible surfaces around junction box is greater than 1/8 inch, the surface must be repaired in accordance with 2023 NEC Article 314.21. The receptacle yoke, frame, must rest on the finished surface and be firmly held at this surface as per Article 406.5a, 2023 NEC. If the receptacle yoke, frame, cannot be firmly held at the finished surface, too large gap between the finished surface and the junction box, a spacer must be used between the receptacle yoke and the front of the junction box to firmly secure the receptacle to the junction box. Electrical outlet spacer and spacer made of a wire nut. The spacer is installed between the receptacle yoke and the front of the junction box, so that the bottom surface of the yoke is flush with the finished wall surface. The spacer is installed under the receptacle yoke. If it is necessary to install an adjustable junction box extension, a spacer, if needed, should be placed under the extension, between the extension and the front of the junction box. A receptacle wall plate that covers the receptacle opening and is flush with the finished surface must be installed in accordance with 2023 NEC Article 406.6. Installation of a duplex receptacle in junction boxes with 5 wires that will be connected to the receptacle after splicing. Sketch of the junction box with 5 wires that will be connected to the receptacle. Sketch of a connected duplex receptacle. The junction box with 5 wires that will be connected to the receptacle. Make a loop at the end of each wire. Ground wire. Neutral wires. Hot wires. Connect the ground wire, bare, to the ground terminal, green screw, of the receptacle. Connect the neutral wires, white, to the neutral terminal, silver screws, of the receptacle. Connect the hot wires, black, to the hot terminal, gold screws, of the receptacle. Secure the receptacle to the junction box and install the receptacle wall plate. Pull the spliced wires out of the junction box. Strip the insulation from the ends of the wires about 1/2 inch and make loops in the ends of the wires. Connect the ground wire, bare, to the ground terminal, green screw, of the receptacle. Connect the neutral wires, white, to the neutral terminal, silver screws, of the receptacle. Connect the hot wires, black, to the hot terminal, gold screws, of the receptacle. Secure the receptacle to the junction box. Level the receptacle and install the receptacle wall plate. Installation of a combination type, double, single pole switch. The most common single pole, double, switches used in homes are traditional style and Decora style. Both switches are made in the similar way, they only differ in the front face look, front view, and rear view of the traditional single pole switch. Yoke, frame. Switch handles for turning on and off. Ground terminal, green screw. Hot common terminals, black screws. Side view of the switch. With hot common screws. A bridge connecting two hot common terminal screws that can be removed when the switch is connected to two different power sources. A1 and B1 load terminals for controlling two separate light outlets. Side view of the switch. With A1 and B1 hot load terminals. The terminals of the switches are usually rated for only one wire under one screw. Screws securing the switch to the junction box. Threaded holes for mounting the switch wall plate. Cuttable switch yoke ears supporting the device on the wall that can be removed if necessary for certain installations. According to Article 404.8 of the 2023 NEC, multiple switches, grouping more than one, must be marked that they can be supplied from more than one circuit. The following installation description for single-pole switches applies to all types of wall switches in accordance with NEC Article 404 of the 2023 NEC. Switches must be used in accordance with their ratings as specified in Article 404.14 of the NEC 2023. Switches should be mounted using the hardware provided with the device or machine screws with a 32 threads per inch. Do not use drywall screws, as per Article 404.10, b. 2023 NEC. Neutral wire is required at the switch location specified in Article 404.2, c. of 2023 NEC. All metal parts of the switches, yoke, metal faceplate, must be connected to the equipment grounding conductor as per Article 404.9, b. 2023 NEC. Do not connect more than one wire to the hot terminals, gold screws, of the switch unless is rated for more wires. Instead, properly splice the wires in the junction box before connecting them to the switch. Wires should be tightened to a torque of 14 to 18 inch-pounds for standard electrical devices unless otherwise noted by the manufacturer on the device or in its installation instructions. Without using a torque screwdriver, the wire under the electrical device screw should be tightened firmly, but not too tight so as not to damage the wire and the threads of the screw or nut. Always connect the wires clockwise, not counterclockwise, because connecting clockwise pulls the wire in and secures it, while connecting counterclockwise pushes the wire out, which degrades the quality of the connection and makes it poor. Never connect more than one ground wire to a single ground screw unless it is rated for multiple wires, as this creates a poor connection and does not provide a reliable ground fault current path. Instead, splice all ground wires together and connect only one wire under the ground screw. It is acceptable to wrap the ground wire around the ground screw to pass the ground wire to another device in a daisy chain connection. When attaching the switch to the junction box, pay attention to the gap between the upper edge of the junction box and the surface of the installed drywall. The gap between the surface of the finished wall and the top of the installed junction box must not exceed 1/4 inch according to Article 314.20 of the 2023 NEC. Junction box extender, adjustable depth, with mounting screws. If the gap between the finished surfaces with non-combustible material and the top of the installed junction box is 1/4 inch or more, a junction box extension must be installed, per Article 314.20 and 314.22 of 2023 NEC. Where surfaces are finished with combustible material, Extensions should always be installed to extend the junction boxes to such surfaces. If the gap between non-combustible surfaces around junction box is greater than 1/8 inch, the surface drywall must be repaired in accordance with 2023 NEC Article 314.21. The switch yoke frame must rest on the finished surface and be firmly held at this surface as per Article 404.10 B, 2023 NEC. If the switch yoke frame cannot be firmly held at the finished surface, too large gap between the finished surface and the junction box, a spacer must be used between the receptacle yoke and the front of the junction box to firmly secure the switch to the junction box. Electrical outlet spacer and spacer made of wire nut. The spacer is installed between the switch yoke and the front of the junction box, so that the bottom surface of the yoke is flush with the finished wall surface. The spacer is installed under the switch yoke. If it is necessary to install an adjustable junction box extension, a spacer, if needed, should be placed under the extension, between the extension and the front of the junction box. All switches must have switch wall plates that covers switch opening and are flush with the finished surface as per Article 404.9 A, 2023 NEC. Installation of a combination type, double, single pole switch in the junction box spliced to control a fan, light fixture. A properly spliced junction box for a combination type, double, single pole switch should have 4 wires that will be connected to the switch. Sketch of the switch junction box with wires that will be connected to the combination type, double, single pole switch. Sketch of a connected combination type, double, single pole switch. The junction box of a combination type, double, single pole switch has 4 wires that will be connected to the switch. The switch connection is shown in the example of the switch connection in a different junction box. Ground wire. Hot wire from the cable from the power source. Hot wire to connect fan from cable to the fan, light outlet. Hot wire to connect light from cable to the fan, light outlet. Connect the ground wire, bare, to the ground terminal, green screw, of the switch. Connect the hot wire, black, from the cable from the power source to the hot, common, terminal, black screw, of the switch. Connect the hot wire, black, to the fan from the cable to the fan, light outlet to the one of the hot load terminals, A1 or B1, gold screw, of the switch. Connect the hot wire, red, to the light from the cable to the fan, light outlet to the other, free, hot load terminal, A1 or B1, gold screw, of the switch. Secure the switch to the junction box and install the switch wall plate. Installation of the paddle fan with light in place of the center light fixture. The 3-wire cable that is present in the light outlet junction box is installed from the switch junction box, from where the paddle fan light can be controlled using a combination type single pole switch. Paddle fan with light which can be installed to the junction box. Articles 314.27 C and 422.18 of the 2023 NEC address the support and location of a paddle fan, and the installation described in this video meets all of these criteria. Although the NEC does not specify a minimum distance from the floor to the blades of a paddle fan, Article 110.3 B states that the manufacturer's instructions, supported by the International Residential Code, IRC, and the Occupational Safety and Health Administration, OSHA, must be followed. The instructions for all paddle fans strictly specify the safe distance of the fan blades from the floor if the blades are not guarded to prevent accidental contact, with the minimum distance from the floor to the lowest point of the blades being 7 feet. Article 422.18b of the 2023 NEC specifies clearances for a paddle fan installed in bathrooms only. Minimum 7 feet to the lowest point of the paddle fan blades. Also, the distance between the paddle fan blades and the wall must be maintained as specified in the instructions. Sketch of the light outlet junction box with wires that will be connected to the paddle fan, light fixture. Sketch of a connected fan, light fixture. Wires in the junction box that will be connected to the paddle fan, light fixture. Ground wire, bare. Neutral wire, white. Hot wire, black. Second hot wire, red. Wires from the paddle fan, light fixture that will be connected to the light outlet junction box. Ground wire, green with yellow stripes or can be green or bare. Neutral wire, white. Hot wire from the fan, black. Hot wire from the light, blue. The connection of the wires from the fan, light fixture to the wires from the junction box when the fan, light fixture is controlled by the switches shall be done as follows. The ground wire, green with yellow stripes or can be green or bare, from the paddle fan, light fixture, must be connected to the ground wire, bare, from the junction box. The neutral wire, white, from the paddle fan, light fixture, must be connected to the neutral wire, white, from the junction box. The hot wire, black, from the paddle fan, light fixture, must be connected to the hot wire, black, from the junction box. The second hot wire, blue, from the paddle fan, light fixture, must be connected to the second hot wire, red, from the junction box. Ceiling fan hunter, Tustin, data, for indoor installation. Fan blades span after installation 52 inches. 3 mounting options. Standard, low, angled. Light kit included. 3 speed options controlled by pull chain. Light controlled by pull chain. Fan must be installed on approved ceiling fan junction box or directly to the building structure. Even if a fan will be installed directly to the building structure, ceiling junction box is required and must be installed. Distance 7 feet from the floor to the lowest point of the fan blades must be maintained for safety and to meet NEC, National Electrical Code requirements. Also minimum 30 inches distance from nearest wall or obstruction to the tip of the fan blades require. This example shows angle mounting option for ceiling angle less than 34 degree. Less than 34 degree. For ceiling angle greater than 34 degree, angle mounting kit must be purchased. Slope ceiling mounting requirements. Minimum 7 feet distance from the floor to lowest point of the blades. 30 inches distance from the tip of the blades to the angle ceiling or any other obstruction. Must be installed on a junction box approved for fan support. Longer downrod. Downrod must be long enough to maintain blades clearance from the slope ceiling. If downrod is not long enough, a fan junction box must be moved up to make proper clearance from the tip of the blades to the sloped ceiling. Installation steps for a new fan replacing existing old fan onto existing junction box in slope ceiling. Before any work with existing fan, turn the power off, not only a switch if installed, to avoid electrocution during the work. Disconnect and remove old paddle fan. Remove bracket supporting old fan. Inspect the old fan junction box. Fastening to the structure. Wiring. And a label. Make sure that the junction box is acceptable for fan support. Paddle fan box contains fan body, fan blades, light kit globe, support bracket, fan wiring canopy, fan wiring canopy screws, wire nuts and screws with washers for fan direct mount to the structure, washers for fan blades attachment screws, fan blades attachment screws, light kit attachment screws, longer screws to attach light kit to the fan housing, short screws to install plate for switch housing, pull chain pendants, fan balancing weights, spare parts, standard downrod, shorter downrod for low profile installation, switch housing cover plate, fan lighting kit, light bulbs. Instruction. For angle ceiling installation, downrod for standard application must be replaced by longer downrod. Downrod for standard installation. For installation using the standard fan downrod, omit steps for hardware transfer from standard downrod to any other. In this installation, place wiring canopy on the fan body. Pass wires through the downrod. Screw downrod to the fan body and tighten the security screw. Long downrod. Remove red warning label. Loosen security screw so the fan rod tread is free of this screw. Pass the wires through long downrod. Downrod's treaded side shall face fan body. Screw downrod into fan body tread till will be tight, at least 4 to 5 full turns. Tighten the security screw using adjustable wrench or pliers. This is critical step to prevent fan fall down. Transfer hardware from standard downrod to the longer. Disassemble the standard downrod. To do that, first of all unscrew the top screw. Next, slide down downrod hanging ball and remove it. Remove metal pin. Remove plastic opened bushing. Unscrew and remove downrod grounding screw and wire. Standard downrod assembly parts. Top screw holding the hanging downrod's ball. Ground wire. Ground wire grounding screw. Metal pin. Plastic opened bushing. Downrod's hanging ball. Downrod. Prepare new downrod for hang. Fan wiring canopy. Slide wiring canopy onto the downrod. Slide downrod's hanging ball onto the downrod. Attach ground wire to the upper hole of the group of 2 holes using grounding screw. Insert plastic opened bushing onto the fan downrod. Slide up the downrod the opened plastic bushing. Match the holes for the metal pin. Insert metal pin into the holes. Slide up the downrod hanging ball. Match notches on the hanging ball with the metal pin. Secure downrod's hanging ball with the screw. Completely assembled fan body ready for a hang. Fan hanging bracket. Attach fan hanging bracket to the fan-rated junction box. Tighten the screws. Open side of the hanging bracket must face peak of the ceiling, otherwise fan may fall off and create a hazard for occupants. Ceiling fan ready to be hung. Raise the fan and insert downrod's hanging ball into the bracket through the bracket opening. Turn right or left if necessary to make downrod's hanging ball sitting correctly in the bracket. Trim fan wires to desired length, not less than 6 inches. Strip ends of wires about 1/2 inch. Wire nuts supplied. Connect ground wires, green with yellow stripe, from downrod and bracket to the ground, bare wire from the junction box. Insert connected wires into the junction box. Connect neutral, white wire from the fan to the neutral, white wire from the junction box. Insert wires into the junction box. Connect hot, black, from the fan and hot, blue, to the light kit wires to the hot, black, wire from the junction box. Insert wires into the junction box. If the existing fan had 2 switches controlling it, the junction box shall also have another wire, usually red. In this situation, connect fan hot, black, wire to the hot, black wire from the junction box, and also connect the hot fan light kit, blue, wire to the other hot wire, usually red, from the junction box. Fan wiring canopy. Fan wiring canopy screws. Fan wiring canopy already inserted on the downrod in previous step. Slide fan wiring canopy upward the downrod and rotate canopy it to match holes in the bracket with the holes in the canopy. Secure fan wiring canopy using 2 canopy screws provided. Tighten both screws. Fan blades. Fan blades attachment screws. Washers for fan blades attachment screws. Before installation of the fan blades, check a label on the blades. Some fan blades are reversible. Both sides can be installed in up or down position, but some not. Fan blade slot. Center screw. Slots for fan blade screws. Fan blade notch for center screw. Insert the fan blade into fan blade slot and slide the notch of the fan blade onto the center screw on the fan. Secure the fan blade with fan blade screws with washers. Tighten the screws. Repeat this with the other fan blades. Light kit front view. Light kit back view. Light kit holes to fit pre-installed assembly screws. Light kit hole for third assembly screw. Light kit assembly screws, longer. Switch housing plate assembly screws, shorter. Remove the rubber band securing the plug with the cables for transportation. Fan plug connector for the fan light kit. Fan housing screw holes for fan light kit installation. Partially install the 2 lighting kit mounting screws in any of the 3 holes in the fan housing. Feed the fan plug connector through the center hole in the light kit assembly. Align the keyhole slots for pre-installed screws of the light kit assembly. Push up the light kit to insert screws through the holes and twist counterclockwise. Insert third screw through the round hole and screw into the screw hole. Firmly tighten all 3 screws. Line up the color marking on the connectors and connect fan housing connector with light kit connector. Push all switch housing components into the switch housing. Switch housing cover plate screw holes. Switch housing cover plate. Switch plate cover screws. Install switch housing cover plate using cover plate screws provided. Install supplied light bulbs into the sockets. Never install light bulb exceeding wattage provided on the label. Globe. The globe notches. Fan light kit tabs. Align the notches in the globe with the tabs in the light kit. Lift the globe and turn clockwise 1/3 of the full turn until it stops. Check to ensure that the glass is properly secured. Fan pull chain. Light pull chain. Remove and discard the plastic connectors from the ends of the short pull chains. Attach the fan pull chain pendant to the short chain of the fan control switch. Attach the light pull chain pendant to the short chain of the light control switch. Restore the power. Fan blades balancing kit. Attach balancing weights to the fan blades if fan need to be balanced. Example of the fan balancing weights installed. Fan blades reversing switch. To reverse fan blades, remove the globe and slide the reversing switch to opposite position. Reinstall the globe. In the place of combination type, double, single pole switch. Any switch controller suitable for installed fan light can be installed.